Welcome to this short video designed to accompany the practice quiz for the digital badge on exploring relationships and graphs. The digital badge is part of the Data Science for All seminar series designed to introduce big data and data science topics to college students with no prior programming experience. If you stumbled upon this video and want to learn more about the seminar series, please visit us at the URL listed here. When studying for the digital badge, we suggest trying the practice quiz and then clicking on the link in for this video and the answer explanation. Similar to all of the other materials in the seminar series, this presentation is provided under the Creative Commons Attribution Share Alike license. In this video, we will be using the Neo4j sandbox on movie recommendations. The sandboxes are made available by Neo4j and covered separately by their license. Please see the Neo4j website for the terms under which they make their system available. It is not covered by this license. The question covered in this video is based on the Neo4j sandbox for movie recommendations. If you have not created a sandbox, please see the instructions in Canvas. If you stumbled upon this video, you too can follow along by creating a free sandbox at the URL shown here. The question we are going to ask of the data in this video is which genres have the movies directed by D.W. Griffith been in? Before writing our query, we should understand what data we have in the database we are working with. To do this, run the command call db.schema.visualization. In the seminar we called the command db.schema, but Neo4j has since added additional capabilities, so that command has been changed slightly. To keep this output panel displayed, you can even click on the pin icon to keep the schema output at the top of all of the output panes. Based on our question, we can whiteboard the path we are looking for. First, let's identify the nodes in the path. We are looking for the genres of movies by a director, so based on our schema, our path contains genre, movie, and director nodes. We have some additional information in that we are looking for a specific director, D.W. Griffith. Whether we can use that information depends on whether it's a property on the director nodes in our schema. As we did in the seminar, click on the database information icon in the Neo4j toolbar on the left-hand side of the screen. When the database information panel appears, click on the director node label. Neo4j will automatically then generate and run a query to show 25 director nodes. Here the node for D.W. Griffith is shown, but for this purposes, it does not need to be one of the 25 nodes shown, and generally would not be. But if we click on any of the director nodes, we will see the properties for that node at the bottom. The name of the property is in bold, and the value for that particular node is then shown next to it. Here we see that the name of each director is contained as a property that, not surprisingly, is called name. We can then add that to our query path. Using schema features recently added to Neo4j, we can take an alternate approach to seeing all the properties available for each node type. When you run the db.schema.nodeTypeProperties command, Neo4j will display a table of all the properties that could exist for each node type. Here we can see that the director nodes have a single property, the name property we want to use, and it's required for each director node. In our whiteboarding of the query path we want to write, we'll add the property criteria for the director node. Although we would expect directors, or actors for that matter, to have names, it's important that we checked first to make sure what the name of the property is. If we included the name property in the query, but whoever created the database had named it something else, such as dir name since it's a director, our query would return no results, since we would be specifying a property that does not exist. We now need to add the relationships to the path on our whiteboard. We will start at the end of our question in this case. So we are looking for movies directed by the director D.W. Griffith. We have whiteboarded nodes for directors and movies. We've also specified that we only want director nodes where the name property has the director we are looking for. Looking at the schema, we see that the only relationship between directors and movies is directed, and that the relationship points from the director nodes to the movie nodes. We will add that relationship to our whiteboard. Adding that relationship to our path means that only movies directed by D.W. Griffith will be returned by our query. The other relationship described in our question is we want to know the genre of the movies found by our query path. Looking at the schema again, the only relationship in the database between movie and genre nodes is the in-genre relationship that goes from a movie node to a genre node, which is what we want. So we will add it to our query path. We now have the entire query path for our question whiteboarded, so we can start writing our query based on it. As we discussed in the seminar, the query path uses a pair of parentheses to indicate a node and a combination of dashes and the greater or less than symbols as arrowheads to show the direction of relationships. The first node in our path is the genre node. We need to assign it a variable name, and so we'll use G as a variable name. For this node, we want a variable name because we want to be able to return just the genre nodes or just properties about those nodes. On the whiteboard, there is an in-genre relationship pointing to the genre node. So we add that to our path. Since we don't want to return any properties of the in-genre relationships in our query results, we don't need to provide a variable name. There is a movie node at the other end of that relationship, so we add a movie node to our path. Again, we won't want just the movie nodes or their properties, so we don't need a variable name here. Next on the whiteboard is a directed relationship pointed at the movie node, so we add that. The type for the path is important here, since the schema shows that there are three types of relationships that point at a movie node, and all three types of nodes that are on the other end of that relationship could have a name property. This is different from the in-genre relationship, where it's the only relationship going from a movie node to a genre, so if we left out the type, our query still would have worked okay. The last part of our path on the whiteboard is the director node, so we add that. But we also need to specify the value for the name property. In a node or a relationship, any property values included in the query are shown in a set of curly braces, and the property name and value are separated by a colon. Here the name of the director as a value is enclosed in quotes because the name is alphanumeric, which in programming is known as a string. Now that we have whiteboarded the path and turned it into a cipher query code, we need to complete the query. Every query starts with a match clause that specifies the path, which we just created, and a return clause that says what we want back. Since we first want to see the actual graph of all the paths that match this query, we'll assign the variable name p to the path in the match clause. Although we'll later modify our query to return just the names of the genres this director directed, we'll first see all the matching paths, so we return p. We'll also include a limit of 25 here, just in case this director has directed hundreds of films. Let's run this query. When entering the query, at the end of the first line, press the Shift and Enter keys to continue as a multi-line query. If you just press Return, we'll try to run the query, but without a return clause, your query will fail. The query result looks reasonable and what we expected as far as nodes and relationships. We also see that we can remove the limit of 25 since this director only has 2 movies in the database. Instead of returning the full paths that are found, since we only need the genres, and we provided a variable name for the genre node, we can just return the names of the genres. Clicking on the war genre node, we can see in the footer of the output pane that the property we want to return is the name property. Modifying our query to return only the name property of the genre nodes, which have the variable name G, we get the tabular results shown here. You may have noticed that we also added the word distinct for returning the genre names. Otherwise, since both properties for this director are in the drama genre, that genre would be listed twice. This concludes writing and running the query to answer our question. By first whiteboarding the path for our question, even when the query is relatively simple, it is much easier to write the code.